In this video, we're going to review the flowchart that will help you write names and formulas when you have ionic and covalent compounds mixed. Let's practice using the flowchart to change a chemical formula into a chemical name. Example 1. SR3N2. Does it have 3 or more elements? No, it does not. Does it start with a metal? Is strontium a metal? Yes, it is. We're going to follow this column. This means that it's an ionic compound. We're going to name the metal, and then we are going to change the nonmetal so that it ends in IDE. So I would call this strontium instead of nitrogen, nitride. Let's try another one. Okay, N2O3. We'll change colors here. Red. Does it have 3 or more elements? Once again, no, it does not. And nitrogen. Nitrogen is not a metal, but it is a nonmetal. So let's look how we name it. It's covalent. We're going to use our prefixes to identify the number of each element. So we're going to write the name, still using the IDE, and then we're going to use our prefixes to tell us how many. So, 2 nitrogens, I call that dinitrogen. 3 oxygens, I call that trioxide. So the name for this one, dinitrogen, 2 nitrogens, trioxide, 3 oxygens. Let's try the last one. I'll use blue. CuSO4. Does this one have 3 or more elements? Yes, it does. That means that somewhere in it is a polyatomic ion, and I'm going to find it and circle it. Not a polyatomic ion? Yes, a polyatomic ion. When I name it, I'm going to use the name for the polyatomic ion. So the name for this one, copper. SO4, I call sulfate. And that's how you write names from formulas. Now, if we want to write formulas from names, here's what it looks like. So in this slide, we're going to work on writing formulas. You're going to look at the name and you're going to decide one of 2 things. Does it have prefixes, meaning it's covalent? Does it not have prefixes, meaning it... Okay, we're back. So we're going to look at the name and decide if it has prefixes or no prefixes, and then we'll follow the rest of the rules. Let's look at this first one. Phosphorus triiodide. Tri is a prefix, so we're going to follow this column right here. If it has prefixes, that means it's covalent, and we're going to use the prefixes to identify how many of each element. Since it just says phosphorus, that means there's 1. I'll just write a P. Triiodide tells me that there are 3 iodines. So there's the formula. Let's try another one. Silver oxide. Do I see prefixes? No, I do not. So it's no prefixes, meaning it's ionic. I'm going to write the cation in its charge, and your cation is always a metal. I'm going to write the anion in its charge. The anion is always the nonmetal. Cations have a positive charge, anions have a negative. So silver is Ag. If I look up on my chart, it has a +1 charge. Oxygen is O. If I look it up, -2 charge. Crisscross my charges, I get a formula of Ag2O. Let's try the next one. Calcium phosphate. Once again, no prefixes, so it's ionic. I'm going to first write my cation, calcium. Look it up, you'll see that it's a +2 charge. Phosphate doesn't end in IDE, it ends in ATE, which means it's a polyatomic ion. Look on your chart. You'll see that it's PO4 with a -3. So when I crisscross my numbers, I'm going to write it over here, calcium gets the 3, phosphate gets the 2. But if I write it like that, it looks like I have 42 oxygens, and I definitely don't. So I want to put my phosphate in parentheses so that I know that I have 2 phosphates. Okay, last example. Dinitrogen octaoxide. Once again, we have prefixes, so we're back here under covalent compounds. We're going to use our prefixes to identify how many of each element. Dinitrogen tells me I have 2 nitrogens. Octaoxide tells me I have 8 oxygens. Hopefully this helped you be able to name and write formulas for ionic and covalent compounds.